Welcome, everybody. This is session 2A. Make sure you're in the right class. We'll be talking about organic chemistry, reactions of alkyl benzene. Take out your notebooks, please, and there will be a short quiz. I'm Don Hughes, obviously a chemist, used to be an engineer, took that hat off a few decades ago. So welcome. And we're going to be talking about official title, how do we best manage the risks of PFAS discharges to wastewater and waterways, with a special emphasis on New York State. And question mark indicates that maybe we don't know all the answers, but hopefully we'll have some answers. We have 4 distinguished speakers. I'm going to turn the mic over to David Sonnenfeld, who is an emeritus professor here at SUNY ESF and has assisted not only last year, but this year. Thank you, David.
All right, again, welcome to ESF. And it's my pleasure to introduce Don as the moderator for this session. Don is an ESF chemistry alum and currently teaches chemistry at Lemoyne College here in Syracuse, and is the conservation co-chair for the Atlantic chapter and Central New York group of the Sierra Club. Don will introduce the other members of this afternoon's panel. If anyone needs to use the restroom, it's straight out and to the right back here. So welcome to ESF.
Thank you, David. I'll introduce folks as they come up. All right, so let me see if I can figure out the technology here. Yes. Okay, so I'm going to give just a real brief intro to PFAS. I know we had a session this morning about destruction of PFAS. So just so we're on the same page about what PFAS is, perfluoro and polyfluoroalkyl substances, and they're colloquially known as forever chemicals because they do not break down entirely. Some of them don't break down at all. And the underlying chemical theme is that has one fully fluorinated carbon atom in the structure. 2 examples shown here: trifluoroacetic acid, which is a common worldwide distributed pollutant. It's the simplest of the PFAS, one of the simplest. And then PFOS, notice the distinction refers to one specific compound, perfluorooctane sulfonic acid, one of the easier to pronounce PFAS names. These critters have been around for quite a while, developed in the 1930s. They were used on the Manhattan Project in the 1940s. And then they got into commercial production starting sometime in the 1950s. 3M out in Minnesota, DuPont were the big producers in this country. It is, there are currently about 12 manufacturers in the world. The concerns about health effects didn't come around until the 1970s. And I started working in environmental consulting in the 80s, and we didn't know squat about it. We'd never heard of PFAS. So really, the regulatory concerns environmental concerns didn't start hitting the fan until late 90s, early 2000s. And there since have been some phase outs. I'll show you one of them, which is that 3M stopped making perfluorooctanoic acid in the early 2000s. So people are trying to get away from these things to a degree. What is attractive to industry about PFAS is these kind of properties that you see listed here. They're both lipophilic, in other words, anti-oil and anti-water, hydrophobic. And so they're great at stain repellents. That makes them useful for firefighting. They are non-flammable. They migrate to interfaces. They have been adopted by the semiconductor manufacturing industry for many applications. And they are used as lubricants and adhesives, and you might find them on your dental floss. Environmental concerns, they're very persistent. As I mentioned, the perfluorinated part of the molecule does not break down. And I'll talk about transformations that can happen. Unlike the classic chlorinated pollutants that of years past, DDT, Mirex, PCBs, those kinds of things, which are lipophilic and hydrophobic. These things, many of them are mobile in water because they have an ionic tail. They're surfactants. That's one of the main reasons that they're used industrially, so they stick to surfaces and interfaces. You find them at the air-water surface. You find them on solids, adhering to solids. They bioaccumulate. So this is one of the major concerns about PFAS, is that they accumulate in organisms and they move up the food chain. So they biomagnify, similar to mercury. And then finally, they're very toxic. So that's why we're here, talking about PFAS. If they were non-toxic, who cares? And at the part per trillion levels. This graphic kind of breaks it down into the per versus the poly. So on the left, you're seeing the perfluoro. And let me see if I can make the mouse to work here. So you see the perfluorinated tail here. This is 8 carbons. This is PFAS. And then you see a group on the end. So all of these varieties of PFAS compounds have a perfluorinated tail, and then they'll have some functional groups on the end. As opposed to polyfluoro, which have a perfluorinated tail, but then they also have some non-fluorinated carbon chain attached to it. And a lot of these are the fluorotelomeres. And these are still in use in industry. I want to illustrate that there are transformations possible with PFAS. So I said they don't break down. Well, they don't break down fully. So what can happen is these polyfluoro compounds can lose the non-fluorinated section of the molecule and get transformed into a perfluoro compound that keeps this. And you can also have alterations of the functional group. So here you see that this is an amide group here that got chopped off, leading to a sulfonate. This has been compared to an arrow. So this is from Ian Ross, who works at CDM Smith. He gave a talk to our local techie group. And he compared this to that the perfluorinated is the stone arrowhead. And the non-fluorinated section is the wooden shaft. The wooden shaft can degrade. You shoot the arrow, it goes into the soil, the wooden shaft rots away, leaving the stone arrowhead. Similarly, when you release PFAS into a sewage treatment plant or to the soil, the non-fluorinated section will rot away, leaving the per part. And you'll hear much more about this in subsequent presentations. The other thing I want to convey is kind of categories of sizes of PFAS. So we've heard about short chain versus long chain PFAS in the technology session earlier. But there are also ultra short compounds, and you'll be hearing a lot about that from Roger. So ultra short has 2 carbons or 3 carbons, and then when we get to 4 to 7, it's short chain for the carboxylic acid PFAS, and for the sulfonates, it's considered 4 to 5. Don't ask me why they came up with different numbers. And then everything longer than that is long chain. The PFAS universe. So there's been lots and lots of attention on these guys, PFOA and PFOS. These are the octane 8-carbon varieties. These have been largely phased out, but these were used extensively for firefighting foams and in other applications. The regulatory system has been focused on these 2. The way to regulate compounds is by analyzing for them. This method, EPA 1633 rather, will measure 40 compounds, including those PFOA and PFOS. However, there are thousands of PFAS out there. There's, I think, 4,000 in the chemical abstracts listed. Some subset of that is commercially used, and the whole universe is at least 12,000 PFAS. How can you possibly measure these things? There's 2 methods that I'm going to bring up. TOPS, total oxidizable precursors, which makes those transformations, gets rid of that wooden shaft I talk about. It reduces the number of compounds that you're looking at. And there's also a catch-all, which is total organic fluorine, where you absorb the organic matter and the organic compounds onto a sorbent, and then you can turn all that stuff, oxidize it, turn it into fluoride, and measure the fluoride. Health effects. Health effects have been quite a few health effects. There's several kinds of cancer, kidney, testicular, and possibly breast cancer that have been linked to PFAS. PFAS are also believed to cause liver damage, thyroid disease, and effects on the unborn, and to increase cholesterol, quite a few effects. So both cancer and non-cancer risks. Drinking water standards, last thing I'm going to talk about is this. New York State was very proactive in coming out with drinking water standards. They came out with this, I'm not sure what time, maybe 2020. So 10 parts per trillion for those 2 specific PFAS. And then in 2022, 20 additional compounds were proposed, but that has not gone into effect. Federal government came out with those limits that are listed there in April, and we just found out that the first 2 PFOA and PFOS are still in effect. However, the other two have been put on hold. And on the bottom there, you see this is where we're at with Lake Ontario. This is based on data that's been collected by Onondaga County Water Authority. So the X should be moved down. We still have 4 parts per trillion for PFOA and PFAS. And that concludes my talk. So let's bring Evan up here. And I'll give you a little intro. So Evan Walters, I guess I'll use this, Assistant Engineer, Permit Writer for New York State Department of Environmental Conservation at the Division of Water. For the last 3 years, their daily duties have included writing wastewater discharge permits, reviewing engineering designs and reports, analyzing the performance of wastewater treatment technologies. Evan's got a Bachelor of Science in Chemical Engineering from RPI and has worked as a manufacturing engineer prior to joining the state DEC. Thank you, Evan.
All right, so I just want to give you all a little heads up. I'm not very high in the decision making for our PFAS work group. So if you've got really nitty gritty questions for DEC, I will likely be deferring you to other people, but I will do my best with questions later. So thank you, Dawn, for that introduction. Okay. So given the ubiquitous nature of PFAS, DEC, Division of Water, we've had to figure out a way to tackle this problem. Developing a strategy and priorities involves a great deal of collaboration with other agencies, other bureaus, divisions within our agency, even other states and EPA. This collaboration is critical to success, which is why it's at the core of the image on screen. In the big picture, we're working to identify the priority, collect data, modify permits, and consider adjustments to the strategy, and so on. The diagram appears cyclical, but in reality, all of these pieces feed one another. Yeah. So, what was that first step? Identifying priority. There's many different industries discharging treated wastewater to New York State. And our first step was to identify the industries that have the potential to discharge PFAS compounds in their wastewater. The second step was identifying the drinking water watersheds where the greatest risk is to human health. Put those two factors together and you get the focus of our TOGS 1313. TOGS is our Technical Operational Guidance Series. It's our main policy in DOW for speedies. So TOGS 1313 focuses on these priority industries. There's a list of SIC codes, and that is continually updated as we learn more about each industry. For example, semiconductors were not in our original list that was published with TOGS 1313. We have a list that we update, and semiconductors were added when we learned more. POTWs, publicly owned treatment works, your municipal treatment plants require a different strategy than industrials because they don't have direct control over what's coming into the system. Similar to industrials, we have a draft TOGS 1314 focusing on POTWs within the drinking watershed. This strategy, TOGS 1314, also recognizes POTWs which land apply their biosolids as another priority for focus because groundwater is a potential drinking water source. We have developed a web page which has all of this information, all of the requirements, resources for facilities which receive requests for information. We have links to a survey that they're supposed to be giving their sample results through. We have a portal for that. We're collecting chain of custody, lab results. We have lab result templates, and we have sampling tips for collecting these samples, as well as checklists for track down and source control. This webpage will continue to be updated as we learn more and as we develop more resources for dischargers. We have also updated our permit applications so that any permittee that is coming in for a modification or a renewed permit, they have to submit PFAS samples with their application. It doesn't matter how big you are or what kind of industry you are. If you're coming in with a speedies application, we're requiring PFAS sampling as part of that. So later I'll get into how far we've gotten with those requests for information and where we are with that application data so far. Once we've got data, we have permits to modify. We will modify these permits in accordance with the current strategy based on the data collected. Remember that that strategy is being updated. So what we do in permits may change over time, especially as we're in the very early phases of how we're developing this program. So permits could be modified at this point to include additional monitoring, best management practices, action levels, maybe effluent limitations, pollutant minimization programs, or really any combination of those. In 2024, we sent out 4 rounds of requests for information to industrial facilities identified initially in TOGS 1313. A total of 180 facilities have received those RFIs. So far, landfill leachate, airports, remediation sites are showing the highest detections of PFAS. And we are also seeing low-level detections at sites such as laundromats, car washes, laboratories, metal finishers, paper mills, and more. In 2025, we expect to complete the list of RFIs to those priority industries identified in TOGS 1313, and we also expect to start sending RFIs to those municipal treatment facilities as pending the finalization of TOGS 1314, which we are still working on finalization of that. We're working on response to comments, I believe, at the moment. So all the while we're working on this, we're continuously reviewing all of this data on a holistic level as we receive these applications. While we're looking at that data, we learn more about these industries. Some industries which we might not have previously identified, like I said before, could get added to the list. Another action we take is to increase the score for a facility. So if you're not familiar with our environmental benefit prioritization strategy, there's a rubric for points that get awarded to facilities based on do we know that they need a water quality limit? Do we know that there's a missing piece of the program in their permit? And all those points get tallied up, and the facilities with the highest scores get a permit update the soonest. These PFAS we're adding points to facilities that are identified as being a concern or as actually having PFAS. And so those facilities are getting higher EBPS scores. Highest scores targeted for next year for updates. And on this next slide, this is where we are sharing all of the data and the information. I'm going to go ahead and show you here. So this is our information portal. Ambient data and application data, discharge data from facilities is going into this portal. Go ahead and open it. Okay. So this is our emerging contaminant webpage. This is the one I mentioned before that's got everything where Division of Water is doing with respect to PFAS. If you scroll down on the page, you'll see that there is the Division of Water portal. Agree to the terms, go ahead and get in there. And you can scroll in. We have the first level that is highlighted is facilities. So these are facilities with PFAS data. And you can come in here, and you can actually go ahead and pull the data in data tables yourself. If you have more questions about this, feel free to see me later. We'll go right back to, okay. I'll now mention biosolids, not quite just the water, but DMM, our Division of Materials Management, recently issued their policy back in September 2023, DMM 7. And this involves a joint research project looking at PFAS in biosolids, but also the influent and the effluent. So DOW is working with DMM on this. We're trying to get an idea of correlations between the water and between the biosolids, what's coming out. We also are working on, we have comments on the EPA risk assessment. Those are due in August. We have some now that we're drafting, and we will be submitting those as well. And there are several laws that have already been passed limiting the use of PFAS in products. That is essentially, in a nutshell, where we stand, Division of Water addressing PFAS. The science is evolving as we continue to learn more, as we learn more from research, like many of you are completing in this room. We will update our strategy, we'll update our priorities. And the one last thing I wanted to mention, when we request that data, we are requesting method 1633, so we were getting 40 PFAS parameters. We are focused on PFOA and PFOS with our guidance values, but we are collecting data more broadly. And those are the contacts on screen that will have better answers for the complicated questions for you. Sarah Latessa is really the lead, the go-to for all things PFAS generally, and if she doesn't have the answer, she'll know who will. Dan Rierick is a lead on the ambient monitoring, water quality monitoring, and biosolids will go to Molly Tremblay in DMM. And that's all I have for you.
Thank you, Evan. I should have mentioned, so the layout of the land here is we spend the first hour going through the presentations, and then there's a discussion period, hence the chairs on the stage. Any burning questions? I want to allow a minute or so if there's anything urgent that you want to clarify about what was just presented. Okay. I'm still working on that benzene chlorination problem. Remember, there's a quiz. Okay, so next up is Roger Brewer. I'm so excited that we were able to get Roger to come to our humble burg of Syracuse, most recently from Toronto, South Carolina, China, Hawaii. Little intro to Roger. He is currently an environmental scientist with experience in regulatory compliance audits, characterization of contaminated soil, water, and air, contaminant fate and transport, vapor intrusion, and human health and ecological risk assessment. Current areas of focus include PFAS, chemistry and toxicity of petroleum fuels, improved methods for the collection of representative environmental samples. He has worked as an environmental consultant in the US and Asia, AKA China, South America. Australia is not on here. Yeah, okay, heading to Australia at some point. And spent 30 years as a geologist and risk assessment specialist for the Hawaii Department of Health and the California Environmental Protection Agency. His academic background includes a PhD in geology. So he's just masquerading as a risk assessment guy, just so you know. And postdoctoral research in Nanjing University in China. Take it away, Roger.
Thanks, Don. Thanks for inviting me. I like to wander around a lot. One of the advantages in Hawaii is they really encourage us to go out and find out what other people are doing in the world and take good notes, come back and put it in our guidance. So a lot of what I'm going to talk about today is, I wouldn't call it Hawaii's guidance. It's really a compilation of people. I talked to everyone in the US that could spell PFAS, I think, including in New York, New England states. Also guidance from Europe. They're doing quite a bit of work there, especially managing industrial waste. I think the Europeans are maybe a little bit ahead. And China doing a lot of work. The US does a lot of toxicology. China cleaning up stuff. Australia does a lot of agriculture. So we were a little bit late getting into PFAS. We tried to avoid it as long as possible, but 5 or 6 years ago, someone tested groundwater at a fire training area at an airport, found really high PFAS, so we had to get up to speed really quickly. That's when I got on the phone and on email. So what I was tasked with, our little group, was first find out, what's there. What are the main sources we need to be concerned about? What types of chemicals are there? What's the risk is what I tend to focus on. We'll talk a lot about today. And then what are we going to do about it? What do we need to manage? What can we let go for now? You hear a lot about, you find PFAS everywhere. So we took part of our budget. We're really well funded from EPA and hiked up to really remote areas in Hawaii, up to the top of Mauna Loa, if you know that area, and collected soil samples and tested them for PFAS, and we didn't find any. So hiking in Hawaii is PFAS free if you're interested, come visit. We did find a trace amount at one site. It was right above a city on the cliffs above Kaneohe, if you know where that is, trace levels of PFBA. Otherwise, we're not finding it everywhere. We did find it. There's some references. ITRC, if you're just getting up to speed on PFAS, ITRC has some useful guidance to get you started. It's continually updated. Our guidance, I'll be talking about this a lot today, interim soil and water environmental action levels for PFAS. I put an S on the end just to irritate my friends in the EPA. And we update this regularly. I think it was last updated, maybe in April. And then a field study of PFAS associated with wastewater treatment plants, landfill leachate, AFFF, firefighting foam release sites. We just posted this in April, I think last year, and updated it in April. So we went out and collected samples from all these sites and then tested them for everything, as we'll talk about what we find. Our technical guidance manual talks about how to collect risk-based samples, really good samples in the field, so you don't have to keep going back and back and back. We'll talk a lot about TOPS methods. As a reference here, Ate et al. 2023. There are a lot of papers on TOPS, but I like the way they explained it. I could actually understand it. And we'll talk about that more. We have our webpage, our PFAS webpage down below, a lot of information, a lot of recorded webinars, including about what I'm going to talk about today. It's our field study design. For the wastewater treatment plants, we wanted to get data, a day in the life of a wastewater treatment plant. So tell me what the mean concentration of PFAS is. When I say PFAS, I mean the group in general, not individual compounds, but all these compounds over a 24-hour period at a wastewater treatment plant, just kind of a snapshot. Did the same thing collecting biosolids. How much biosolids does a wastewater treatment plant generate in one day? And we had small plants, maybe 10, 20, 30, 40 tons or so. And we'd collect one sample of the biosolids, collect one sample from 50 points or 30 points within a big pile of biosolids, combine it into a really good multi-increment sample and test that. That's the only way you can get good data. We shouldn't be collecting grab samples of biosolids and things. The lab had to test minimum 5 to 10 grams of the material. That's the only way you can get reliable lab data. Landfill leachate, we had to go with grab samples, balers, hydro sleeves, collecting a quick sample. This is the main thing here. Over time, we started testing for everything. We started off just testing for the standard SGS MLA 110, method 537M, which now they can actually include having a lot, I think the 40 compounds you talked about, it's a little bit cheaper and faster. But then we learned about total oxidizable precursors. We'll talk about that. So we tested our second round of samples for this. See the methods there. And then we learned more. We're still missing stuff. We test for total organic fluorine to try to capture everything that's there for liquids, absorbable organic fluorine, solids, extractable. And what's all this extra organic fluorine we're finding? We tested samples optional for non-targeted analysis. We'll talk all about that. I like this. I forget who sent me to this, Arthur Miller. The apple cannot be stuck back on the tree of knowledge. We certainly found that out. The more we found, it's really hard to ignore. We can't just look at PFOS and PFOA and hexasulfonate. We really have to think about all these compounds. That's what I said, huh? You know, we first started getting this data, you're just overwhelmed if you're just getting started in PFAS. These lab reports are thick, full of acronyms, and every time we get a new study, there's more acronyms and stuff added. We don't have toxicity factors for most of it, so what do we do with all this information? So this is what we started with, is talking with a lot of people on how to manage all of these different compounds, what we're finding from different tests. So what we did, and again, we is lots of people, is we came up with 3 risk-based groupings of PFAS to try to capture the full suite, this complex mixtures. So the first suite we call the primary terminal PFAS. These are the main ones we think about: PFOS, PFOA, hexasulfonate, all these. They're originally present in the sample. Then there's all the precursors. We'll look at those again in a minute. When you oxidize those, they break down into the terminal PFAS. So we get another suite of these terminal PFAS from the precursors. Then we test the sample for total organic fluorine, and there's more organic fluorine in the sample than we would predict based on what we found. There's all this other stuff in there. We just call these excess fluorine PFAS compounds. I want to go through each one of these groups pretty quickly. This is in our guidance, more detailed. I like to keep it simple. The group one, the primary terminal PFAS, most people know what butane, propane are. Kick off the hydrogens out of fluorine, and you've got a PFAS. So go from butane to perfluorobutanoic acid, or butanoate. It's an ionic form in the environment. They use this for textiles, papers, making them stain water resistant. These are the short chain PFAS, 4 fluorinated carbons or less. And then something like octane. We all know what octane is. When you go to, at least to the gas station, you see octane rating. It's just 8 carbons with hydrogens surrounding them. Kick off all the hydrogens, add fluorine, and you've got perfluorooctanoic acid. So it's not that complicated. The terminal ones aren't. So when you get to these precursors, it gets more complicated. And you see these long chains in a lot of different compounds. Used to be in firefighting foam. We compiled toxicity factors for, I think we're up to 25 different PFAS compounds now. So there's a lot more information out there than there was a few years ago. This is from talking to everybody in lots of different states, to the Europeans and to some other groups. So the long chain compounds here are more toxic. This graph here, it shows the relative PFAS toxicity relative to perfluorobutanoate, that fluorinated butane, down in the bottom left here. So the long chain compounds, on average, 100 to 1,000 times more toxic than the PFBA, really toxic ones. Short chain compounds, yeah, they're much less toxic, only maybe 10 times as toxic. They're 10 to 100 times less toxic than the long chain compounds, which is a good thing. Well, then we start comparing the toxicity factors for other common contaminants. And yeah, the short chain compounds are less toxic than long chain, but they range in toxicity equal from naphthalene up to PCBs. So they're still fairly toxic compounds. They're not non-toxic. Gen X is interesting. Gen X should be short chain. It's 2 short chain compounds glued together with an oxygen. It doesn't break down when it gets metabolized, so it acts like a long chain compound in terms of toxicity. I'm sure that surprised the Gen X makers. Well, since we have toxicity factors for all these compounds, we can develop screening levels for them, risk-based screening levels. So this is a summary of this for sulfonates, carboxylates, the toxicity factors we use in Hawaii and elsewhere. So you see for soil on the right, I think it's covered up, says tap water, drinking water. So we have lots of risk-based toxicity factors well beyond just these PFOA and PFOA, hexasulfonate and such. And you can see the numbers in orange. Those are the long chain compounds. The numbers are lower than they are in the green. The green are the short chain compounds. They're lower because the long chain compounds are more toxic. Then you see the blue, these are the ultra short compounds, basically fluorinated propane and fluorinated ethane. We talk about trifluoroacetate. The Germans have done toxicity studies on that. Drinking water, risk-based drinking water number for trifluoroacetate is 18 micrograms per liter. That's micrograms, so it's 1,000 times less toxic than some of the long chains. But we have a number, so when you're thinking about cleaning up, treating drinking water supplies, at least we have a number you can target. But let's get back real quick. For when you think about risk, the way you assess risk is you divide the concentration you find in the sample by the risk-based screening level. That's the ratio. It's called a hazard quotient. If that's less than 1, that means what you found is less than the screening level, then that's good. But if you have a complex mixture of PFAS, you add all those ratios together, all these hazard quotients together, we call that a hazard index. When it exceeds 1, then you need to look at it in more detail. So we can handle these terminal PFAS pretty easily. We have lots of screening levels to compare them to. Group 2 are all these precursor compounds. You see it in textiles, surface wear, firefighting foam. And then if you like chemistry, go out and test wastewater. The metabolites in wastewater are amazing, just a big complex mixture of precursor compounds, partially broken down PFAS. And especially the biosolids are the same way. So these are the precursor compounds, the second suite. We need to be able to put some kind of toxicity to these, assess the risk posed by those. We do that by Don talked about TOPS. So group 2 is this oxidation of precursors, the secondary terminal PFAS using total oxidizable precursors. They just oxidize the sample, and what it does, it breaks off that functional group. It's supposed to mimic what would happen if you ate this stuff and it got inside your body. It would strip off the functional group down to the terminal PFAS, and then so I like to treat it like pruning a tree. You know, arrows, I use trees. So think of all the branches and leaves, small branches they're all the functional groups on a tree that they've stuck to it. When you oxidize it, you prune that tree and you're left with that terminal PFAS compound again. So we can treat these just like we do the primary terminal PFAS. You see the same thing in nature. This is an example of breakdown of the PFAS they use in firefighting foam for the last 20 years into these short chain terminal PFAS. So oxidize the sample, we're left with all these terminal PFAS, the secondary ones, compare those to the screening levels, divide the concentration found by the screening level, calculate a hazard quotient, add them all up together. Now we can address all these precursor compounds that the lab dumps on us in laboratory reports. So you don't have to know the toxicity of all these compounds if they can be oxidized. And so we're looking at cumulative risk from these complex mixtures. So every time we think we're done, we thought we were done when the group 1, we got our terminal PFAS, and then we oxidize it and things show up. I thought we were done here. I talked to some friends in California, and they say, you know, there's all this extra fluorine in the water. We don't know where it's coming from. So the third group of compounds we just refer to as excess organic fluorine PFAS. So now if we've oxidized a sample and if we know the concentration in the compounds, we can predict how much organic fluorine should be in that sample. We had the lab actually test for total organic fluorine, and 9 times out of 10, it's way more than what we would predict based on the compounds we found. These are excess organic fluorine PFAS, refer to them. And the water, I think, is going to be pretty simple. Based on lab chemists we talked to and non-targeted analysis, they think most of these compounds we see in the water, I call it PFAS debris, but they're ultra-short compounds, kind of fluorinated ethane and trifluoroacetate and such. So we assume that this group of compounds for water has the same toxicity as perfluoropropane, fluorinated propane. And talking to toxicologists, they think that's pretty reasonable to do. So for water, we can look at that as excess fluorine, calculate what it would be equivalent to this fluorinated propane, perfluoropropanoate. Now we can compare that to the action level for this compound and look at the risk posed by it. Biosolids, we also see a lot of excess organic fluorine. We'll look at that in a minute. And a lot of these we thought were ultra shorts. I'd read the paper by Schaefer. I'll read that if you have it and you're dealing with biosolids. Probably a lot of phosphate-based PFAS out there in the biosolids, either coming off our clothing or textiles. I don't know. They're definitely out there. We still assume that the biosolids, the extra organic fluorine, has the same toxicity as this perfluoropropanoate, pretty low toxicity. That could be wrong. We're still working on that. But either way, now we take our excess organic fluorine, assume it's all perfluoropropanoate, and we can compare it to our perfluoropropanoate action levels, calculate a hazard quotient. If you got all that, then we'd probably want to hire you in Hawaii. Low pay. But the bottom line here is now we can calculate more total PFAS risk, getting closer to the truth if there's any truth out there. So we add up the hazard posed by these primary PFAS, they're originally in the samples, secondary PFAS where we oxidize a sample, calculate the toxicity and hazard quotients and such. And then excess fluorine PFAS, look at that risk, add all these together, and that's our total PFAS risk. You're just looking at ratios. When this gets over 1, then we may have a problem. And this is just an example of some wastewater effluent I show you. The total risk was 5. It's over 1, so we need to look at it in more detail. 5's not that bad. There are huge safety margins built into these toxicity factors by factor 100 or even 1,000. But we'd want to look at it in more detail. We make this easy. This is an Excel spreadsheet we put together. You basically put in information for your site, select whether you're looking at water or soil. We're actually adding food later on this year. For soil, is it unrestricted residential site or commercial industrial? Just fill that in. If you don't like our excess fluorine PFAS screening levels, you can add your own. And then you just put in your sample data, pre-TOPS data, after oxidation, post-TOPS data. You put that in on the worksheet, put in your total organic fluorine, and presto, it calculates a hazard index, total PFAS risk for you. So it's pretty simple. We got it down just a few minutes doing this. So that's it. So what are we finding? This looks at the effluent versus leachate versus AFFF impacted groundwater, our data. The big green bars there, all this excess fluorine. In every water sample we looked at, there's just way more organic fluorine in the sample than you'd predict. So there's a lot of PFAS debris or whatever you want to call it out there, probably these ultra-short compounds. Landfill leachate, we see more of the primary terminal compounds, PFOA, PFOS, which are a little bit more toxic. When you get to AFFF contaminated groundwater, you see more of these PFOS, PFOA type compounds originally in the sample, but it still dominated. The main group of compounds in there is all these mixture of ultra short compounds. Well, that's the makeup, but we're not that concerned about makeup. We really want to know risk. Because it proclaims the guy was the dose makes the poison, right? So this looks at it converted to risk. So with wastewater effluent, treatment plant effluent, these ultra short compounds, so this excess fluorine, still seems to pose the main risk from effluents. It's pretty important when you look at wastewater effluent, do your total organic fluorine and try to look for ultra short compounds in the sample. Landfill leachate, the landfill leachate's pretty nasty anyway. PFAS is probably the least thing you need to worry about. But there's a lot of these more high toxicity terminal PFAS and landfill leachate that dominate it, and they actually drive risk. For AFFF contaminated groundwaters, these primary terminal PFAS, you won't see a lot of extra organic fluorine as far as posing risk in AFFF contaminated groundwater. That was the water. This is the biosolids versus compost versus AFFF impacted soil. And again, in the biosolids, there's a ton of extra organic fluorine in there. It's probably not ultra shorts like we thought. It's probably all these phosphate-based PFAS. We're not sure about toxicity. You do see a lot of precursors in biosolids. It's fun oxidizing these samples because suddenly the concentration of reported PFAS goes up by an order of magnitude. So this flags you really need to oxidize samples of biosolids. For a compost, we don't see that much precursors because they're breaking down as you're creating compost. For old AFFF release sites, you see a lot of PFOS, not a big surprise. It's what an AFFF. Newer post-2005 AFFF sites, if you only test it for PFOS, you're not going to find anything because they don't use PFOS. They didn't after 2005. If you want to find the contamination, you have to oxidize the sample. And there you'll see the concentration we did go up by 10,000-fold because you're oxidizing all these precursors they use. That's the makeup. Here's the risk. What drives risk in biosolids? It's, from our experience, it's all these precursor compounds in there. You don't see them until you oxidize it. They're hidden. When you do, your concentration goes up, your risk goes way up. So the biosolids, the precursor compounds, seem to drive risk. After you compost it, they're already broken down into these terminal PFAS. So a compost not quite as important. Old AFFF, it's the primary PFAS, the PFOS and such. And again, what drives risk for new AFFF release sites post-2025? It's all these precursor compounds in firefighting foam. So again, if you don't oxidize them, you won't find them. So there's a summary here that, for these three different groups, primary terminal PFAS, before you oxidize the sample, they're always important to understand. They help you understand the forensics of the sources. These secondary terminal PFAS related to precursor compounds, in our experience, they're especially important when you're testing soils and biosolids. Also, wastewater at the source area, before it goes to a wastewater treatment plant, you'll see a lot of precursors. They'll show up when you oxidize the sample. Excess organic fluorine, identify it by testing for total organic fluorine and comparing it to predicted. Really important for water, but it's also going to be important, I think, for biosolids because there's a lot of terminal phosphate compounds in biosolids that don't break down. You can't even see it after you oxidize a sample. But Schaefer et al. In that paper, they did additional studies, said, hey, you're still missing stuff in your biosolids. That's it. It's coming this fall. I've been working more with agricultural people now, risk-based investigation of PFAS impacting agricultural fields and food crops. It's going to be published by CRC Care in Australia. It basically tells you there's a lot of concern about agricultural fields. Which fields do we need to be concerned about? Looking at the history of what kind of sludges, if anything, were deposited there, used there. So how to identify high-risk areas. Then what potential environmental concerns are? They're leaching the groundwater, kids playing in the dirt, uptake in the food crops. Talks about that. And then how to collect proper samples of those from a risk-based standpoint of soil, water. We also added food. So we have screening levels for 26 PFAS compounds for cereals, grains, dairy, fruits and vegetables and such. This will be coming out. What to test for, you really run all three tests on it, and then how to assess risk, which we talked about. Hopefully it'll help clear a lot of these fields where they spread sludge years and years ago. It's already bound up in the soil. What's going to leach out is leached out, and the fields are now okay to grow food crops, but this is the way to test it. So that's it. This isn't perfect. It's another quote. I like quotes. It's better to be roughly right, precisely wrong. And I think when we start looking at all these three groups, we're getting in the ballpark of roughly right. And ongoing research, we have I still do contract work in Hawaii and other places, but we're looking at uptake of PFAS in the food crops. In one case, we're irrigating the food crops on Maui, little garden areas with wastewater from a local wastewater treatment plant because they're short on water. The farmers want to use it to irrigate food crops. I don't think it's going to work, but we're going to irrigate the crops, the plants, and then test lots of different parts of the plants and see how PFAS migrate up through the plants and transform. Also look at leaching of PFAS from soil. The only way to test leaching really is soil column test group in Canada, working with on that. And then last thing I'm focusing on is alternative toxicity factors and screening levels for risk management, because the screening levels now and toxicity factors are so conservative, everything's bad. So where do you start? So I'm working with risk assessments and toxicologists where we can back off a little bit on the toxicology, still be conservative, but now we can say, if it's this high, these are high risk sites, let's focus on these. Medium risk sites, maybe it's advisory or some other kind of risk management, and then low risk sites, looking at some of the really conservative long-term goals, screening levels. So that's it, and happy to take any questions or move on to the next speaker. Thank you. Good to be here.
Any burning questions? I got a burning question. The short chain, you're assuming that they're ultra shorts. Has there been any investigation of that? I mean, you can analyze for ultra shorts, right?
Yeah. So we've been, I guess, the laboratories we're working with, SGS and Eurofins in particular, they can run this non-targeted analysis. They can look at the chromatogram and say, we're pretty sure this is an ultra short compound, trifluoroacetate. They can't give a concentration. Been doing that, and then we're pushing them to actually give us a better data. It's trifluoroacetate, and here's the concentration. But we need toxicity factors for those also.
You got some dice? Oh, we got additional slides. We'll leave these for later. Okay. I'm going to jump ahead here. Am I going the right direction? Yeah. Hang on a second. Let me introduce our next speaker here. This is Dan. Where are my doubts? Oh, I turned the paper over and became invisible. So Dan Rourke, professional engineer, works at Saratoga. He's an alumni of Rensselaer Polytechnic Institute. I've heard of that place. With a degree in civil engineering, he worked in consulting engineering for 7 years, designing concrete tanks, wastewater facility upgrades, water treatment systems before moving into the public sector for the Saratoga County Sewer District. District has serves 160,000 people, give or take, has a 22 million gallon a day treatment plant. He has been in his current position as executive director for about 10 years and has implemented multiple capital improvements for the district in both at the plant and in the collection system. And he is currently the president of the New York Water Environment Association. and an advocate for sensible, clean water solutions across New York State, as most of us are as well. Thank you, Dan.
Thanks, Don. Really good presentation so far today. What my goal here is, and thank you for having me. What my goal here is to kind of talk about what all of this means for those who kind of have boots on the ground, that are running a wastewater treatment plant, running a sewer district, have an industrial pretreatment program, bounce what Evan had talked about earlier on what they're trying to do, and what does that mean for us? What does that mean for Saratoga County and other utilities across New York State as well? I would be remiss, as Don said, I'm the current president of NIWEA. We switch annually who is president, and I'd be remiss not to talk about NIWEA just a little bit. And here's our mission statement. But what I wanted to do is I wanted to ask the question, who in the room has heard of NIWEA, the New York Water Environment Association? Okay, fair amount. Who here is a member of the New York Water Environment Association? Okay, much less. Anyway, yeah, I was gonna say, talk to Chris Dotson. He's our executive director if you're interested. Student memberships are dirt cheap, as are young professional memberships as well. Our goal, as it says, is promoting sustainable clean water quality management through science, education, and training. We have a couple of different entities under within NIWEA, I should say, the GAC, that's our Government Affairs Committee, that's working with legislators right now to understand and potentially influence legislation that's in the New York State Senate and New York State Assembly. I will go through some of those that are out there a little later in the presentation. And then we also have an emerging contaminant task force that is looking more on the technical and science side of things. But those two entities work together to both inform us as NIWEA, inform our members, and try to provide some direction for utilities as we kind of float through this PFAS problem. Just some quick background on Saratoga County Sewer District. We were founded about 50 years ago, 58 employees, 22 million gallon per day facility. Oh, we're getting the dancing again here. And yes, I would love it for it to stop. Thank you. I always go to DEC to solve my problems, so. Yeah. That's right. We serve residential, commercial, and industrial users. I'll go into some of the industrial users that we serve, that are our customers. We also own, operate, and maintain the collection system. We have over 100 pump stations, hundreds of miles of pipes, thousands of manholes. So while, yes, PFAS is a concern, there's also all of these other things on a daily basis that we're dealing with. And then our solids handling currently is we just produce unstabilized sludge off of a belt press, and that gets hauled away by Casella, which is a third-party vendor, and they take it to their Grasslands facility up in Chattagay and Lime stabilize it currently, and that is currently being land applied. We used to incinerate. We shut down our incinerator in 2016 when the new sub 4M regulations came out. All right. So we do have an industrial pretreatment program. We have 6 industries that we regulate. We are the regulating entity for those 6 industries. It is a federally authorized program under 40 CFR. So we regulate both SIUs, which is significant industrial users, which is typically based on flow and the constituents they discharge, but also categorical industrial users. We serve 3 categorical industrial users, and that Part 403 actually defines what a categorical industrial user is, right? So, for example, we serve Stewart's, which is a dairy manufacturer. They're a CIU. We serve Global Foundries, which is a semiconductor manufacturer. They're a CIU. And there's specific limits that they have to hit per Part 403 that we have to implement. I wanted to talk about this. So the goal of this slide is to kind of I want people to understand how, what regulatory authority do we have currently to manage PFAS, to regulate PFAS? Evan touched on it, right? And with the industrial pretreatment program and what they're trying to do through DEC and get data. But what do we have currently? So currently, if you look at 40 CFR, it says that a wastewater treatment plant can regulate really anything that comes into the plant that causes interference and pass-through. Those are pretty broad terms, right? There's plenty of stuff coming to the wastewater treatment plant that could potentially interfere with the process or pass right through and go to the receiving water. So it's a bit of a bear for utilities, for municipalities to use this language to then go upstream to well-funded large corporations and say, hey, you're causing pass-through, we're going to regulate you. And it's not, there's no necessarily a technical reason to regulate it. It's more just using this language. So as Evan talked about, they are looking at data and looking at permits. And what we need to be able to regulate is we need something within our permit, right? And I'll go into that a little bit later with action levels and how we can use those to then go upstream. But one way to use those is through a SUUS ordinance. So most municipalities have what's called an SUO. And in that SUO, they have local limits. And that's where you set your local limit to then say, all right, we can take this much in the treatment plant. We can't take any more because our treatment plant can't handle it. And then you say, hey, industry, you can discharge this certain amount, and then you have to actually divvy it up amongst the industries. You can discharge this certain amount of that constituent to our wastewater treatment plant, and then everything other than that you have to pre-treat. Just a couple permit examples, as I had talked about. Stewart's is a dairy manufacturer. Some of their pre-treatment limits are BOD and TSS. Global Foundries, some of their pre-treatment limits are copper and fluoride. So we're trying to get a little bit ahead of the curve here for sampling, knowing that all of this is coming down the pipe, pun intended, pretty quickly for PFAS. So the first two columns are our influent and effluent samples. We did sample for all 40 compounds. This was just a snapshot of some of the ones that I thought were interesting. Just that first one I thought was interesting. Influent and effluent, lower influent, higher effluent numbers. I know there's some papers out there and some understanding of some transformation within a wastewater treatment plant to actually generate some of these compounds, either through the activated sludge process or sometimes even through drying and higher temperature biosolids treatment. And then industry 1 and industry 2, just some of the influent, their discharge numbers, I should say, as well. So they're kind of all over the place. Some of them are the longer chains, some of them are the shorter chains. But I just wanted to share some of this information because I thought it was interesting. So TOGS 1.3.14, this was also talked about earlier. So I just wanted to talk about some of the challenges with it. We are totally in alignment with DEC when it comes to the solution. We think upstream source tracking and elimination and getting it out of things is the best course of action to deal with PFAS. I don't see a way to treat PFAS at wastewater plants. I don't think that that's really feasible. So we're totally in alignment in the broader solution, but there are challenges. So those SIC codes that were talked about earlier, there's 40 of those. That's a lot, right? I said we had 6 industries that we have to look at. If all of a sudden now we have to go look at 40, now I have one person that does industrial pretreatment, right, at my plant. There's many plants out there that don't have an industrial pretreatment person. I'm lucky enough to at least have one. So I don't know how we get over that hurdle. I think maybe it's, selective sampling, not in the negative way, but knowing where it's likely coming from and understanding that. And then just the costs and the complexity. So sampling for PFAS, it's not quite like clean hands, dirty hands with like mercury, but it is pretty tough. So having the personnel and the ability to do that is not necessarily something that a typical wastewater treatment plant or a small wastewater treatment plant may have. And then the cost, if you're sampling your influent, your effluent, your biosolids quarterly, you're looking at somewhere between $8,000 to $12,000 a year. Budget like mine, good sized budget, $28 million a year, we could probably absorb that. But some wastewater treatment plant that serves, 1,000 people, 1,500 people in a rural part of New York, that's a lot of money. That's a lot of money to them. So not let alone the time and the effort and the understanding to go upstream, look at those 40 SIC codes and figure that out. So that's one of our concerns, one of the challenges. One of the solutions is for us to be able to do it, to regulate PFAS, is modifying permits, as was stated earlier, to put action levels in our permit. So there was a permit that just came out for the city of Oswego, but that went out for comment. We put comments on it. That had the 40 compounds. It had action levels for 2. The rest were monitor. The 2 were PFOA and PFOS, I believe. And what that does is that allows then that municipality to say, hey, I have this in my permit. Industry's discharging to me. You need to do something. You need to start sampling. We need to understand what you're discharging. And then from there, you can use 1.3.14 as once it gets adopted. Once it gets adopted, you could use 1.3.14 to do that source tracking, to force those industries, right, to provide that data, and then potentially, if they need to pre-treat, force them to pre-treat as well. And the other issue with the SIC codes, and the challenge, I should say, is, industries understand what they need to do with pretreatment, with wastewater. Car washes don't, laundromats don't. If I'm going to talk to an owner of a laundromat and say sample for PFAS, he's going to look at me, or she's going to look at me like I have 10 heads, right? It's not who we normally deal with. So there's a little concern on how that's going to actually work if and when we have to implement it. And then finally on this slide, I just wanted to talk about mercury minimization, the comparison. So this was something that was done, I don't know, 20, 30 years ago, where the thought was, let's legislate mercury out of products. Let's use the industrial pretreatment program at wastewater plants to remove it. One big source was actually dentist's office, so amalgam separators. And then let's, over time, hopefully see concentrations drop. And it worked. It worked great, but it didn't work overnight. It took many, many years for this to work. I've seen it at our own plant, mercury levels cut in half. So the comparison to what I think DEC is trying to do with the source track down and the source regulation and the source removal, we have something that's already worked in that way. So why not do it again? So these are some of the proposed legislation, out in the New York Assembly and the House, or I'm sorry, the Assembly and the Senate. I'll get to the circle in a second. That's more of a liability concern. But the PFAS Disclosure Act, that's out there right now, which is basically saying every single entity that discharges PFAS to anywhere needs to submit that data to DEC, and DEC needs to figure out a way to put that information out there. I understand the intent. It's just a very heavy lift. I again, understand the intent, but we're already heading in that direction, right? So I won't go too much into that. The land application ban, there's a bill in the Assembly and in the Senate of New York that wants to ban land application for 5 years in New York. That'll turn biosolids, if it's done in a too quick of a way, that'll turn the whole biosolids market on its head very quickly. It'll cause water quality concerns. It'll cause prices to go up 200%. I'm not necessarily opposed to it. I think we have to figure the science out. But my thing is I think we need to understand what the implications are, and then maybe do it over a certain amount of time, not necessarily right away. And then PFAS product bans, that has happened in some things. We're looking for a more a more ubiquitous ban on it as many things as we can. I know New York State's done product bans on stuff like Gore-Tex and whatnot, but we're looking for it in more places than that. And then I wanted to talk about as a liability concern. So the EPA, a year or so ago, put these compounds as a hazardous substance under CERCLA, and didn't exempt water utilities or wastewater utilities from basically being liable for having these compounds in their discharge. And the reality is we're passive receivers, right? We're not creating PFAS. We're taking it in. And so that makes us then liable. If I'm discharging PFAS, we discharge to the Hudson River, I could potentially be sued by a third party, right? For doing that, because it's a hazardous substance under CERCLA. So that's a concern. We're asking for an exemption. We're not getting very far with that though. So just wanted to touch on biosolids. There's really only 3 ways to dispose of biosolids, right? There's incineration, land application, and landfill. No one's permitting new incinerators. No one's permitting new landfills. So at least expanding the landfills to the extent that we would need it to handle biosolids. And land application, there's the promise of a ban coming out of the state legislature. So there's a lot of risk right now in the industry for biosolids. I could tell you what Saratoga County is doing is we are looking at installing anaerobic digesters. They definitely won't look as cool as these, which is at Newtown Creek down in New York City. These are pretty neat. You can actually schedule tours to walk up on top and see what these are all about. But we're looking to install those. Really, our risk mitigation is looking at reducing volume, right? If you can reduce your volume, you can reduce your risk because you're paying a cost per ton. We did sample our biosolids. I did want to point that out too. You can't really see it on the bottom, but 1.4 ppb for PFOS, and we had a lot of non-detects as well. And that's it. That's it for me. Happy to answer any questions quickly if, yeah. Oh, sure.
So there was Tracy Frisch often online made a clarification is that there's a sewage sludge land application 5-year moratorium. It's not a ban apparently in the assembly.
Yep, no, that's true. It is a moratorium, but the reality is if you put a moratorium on something for 5 years, the logistics to get it back up and running, it would disappear. So I call it a ban. But yes, the bill does say moratorium.
Last but not least, we have Lenny Siegel, who's come here from the West Coast. Lenny's been the executive director of Center for Public Environmental Oversight since 1994. He is one of the American environmental movement's leading experts on both the vapor intrusion pathway and military facility contamination. He's provided technical assistance to and visited scores of community organizations across the United States. He's been writing about the semiconductor industry since the 1970s. For his organization, I should mention he comes from Silicon Valley, the birthplace of semiconductors. He runs 2 internet news groups, Military Environmental Forum and the Brownfields Internet Forum, as well as discussion lists on trichloroethylene and PFAS. He has served or is serving on several ITRC work teams on environmental remediation, including vapor intrusion and PFAS. And in 2018, he served as the mayor of Mountain View, California, the birthplace of Silicon Valley. Thank you, Lenny. Welcome.
Thank you. Good afternoon. So I'm going to focus on semiconductor wafer fabrication because One of the world's largest semiconductor plants is proposed for development not too far from here. The semiconductor industry, that's chips, integrated circuits, considers the use of PFAS essential to production. You know, I was at a meeting of an industry meeting where one of the experts said, you can take PFAS out of a toilet paper roll, but you can't take it out of chip production. So PFAS is not only a forever chemical, the industry considers that it's going to be using some PFAS, maybe a lot of it, for quite some time. Now, it's not the biggest user of PFAS, but the industry is growing. They use hundreds of different PFAS compounds, and they say 1,000 uses. We don't know all the details because this industry relies on confidential business information, so they don't have to tell the public exactly what they're doing. As a matter of fact, they don't always tell us what they're doing when they're doing the right thing. And the industry has phased out PFOS years ago and PFOA by the end of last year. So the problem of PFAS in semiconductor production is growing, and it's different than firefighting foam because they don't use the same compounds. So there are two scenarios for the discharge of PFAS from semiconductor plants in wastewater. The first one is discharge into surface water where there's no publicly owned treatment works involved. And so the factory basically directly releases water into the environment. They may pre-treat the wastewater for other things. I think you mentioned copper and fluoride at Global Foundries, but they don't do any pre-treatment for designed to remove PFAS. One little thing here, the smokestack, the vapor releases are not visible, but they do come out and they release a lot of greenhouse gases. And when they do abate those greenhouse gases, the methods they use redirect some of the waste PFAS into the wastewater stream. So the Global Foundries plant in Essex Junction, Vermont, and their former Global Foundries plant in East Fishkill, New York, discharge directly into surface water. So they're regulated by basically NIPDs or SIPDs permits directly by the state. The more common scenario, which is the case in Saratoga, where the wastewater goes to a publicly owned treatment works, so it not only goes, PFAS not only goes into surface water, but it also is congealed into biosolids, which, as we've heard, can go into agriculture or landfills. So those are two different situations. The Micron plant here will be discharging into a publicly owned treatment works. So you have both the issue of surface water and biosolids. State of Vermont, in their wisdom, figured out that the 5 regulated compounds they were acquiring Global Foundries to sample for, they weren't capturing everything. So they started requiring Global Foundries to use EPA's method 1633, which measures for 40 compounds. And they found that the 5 compounds they used to sample for were just a small percentage of the PFAS that were being released into the environment. And these are sampling that was done before the PFOA was removed from production, as far as we can tell. But this is the data that I was able to obtain, and it shows large number of different compounds that are identified by EPA's method 1633 that are your typical effluent from a semiconductor production plant. But as you may have learned last year, because I borrowed these slides from Don, Cornell did a study, and there's a recent study from China that show that, okay, yeah, there is some release of PFOS and PFOA from semiconductor production, but that, again, this is old data, so it's not too important. But what they found, and some of these may have been the Global Foundries plants, they found that the largest releases of PFAS in semiconductor production wastewater was PFBS. And note this is a logarithmic scale. I guess you can't really see that with the print on here. But it's, again, it's not PFOS and PFOA, it's shorter chain compounds by and large. Oh, great. But more important, waiting for the slide to move. I'll move back. There we go. Another slide from Don. The most important finding in both the Cornell study and the more recent China study is non-targeted PFAS, that is PFAS that are not measured by EPA method 1633, dwarfed all the other contaminations. So if you think of Roger's presentation of all those other chemicals that are not targeted, the releases from semiconductor plants are not the ones that you normally look at. And that means you have to address those, the non-targeted ones, as well as the targeted ones. So you have to measure them, you have to develop risk measures for them, and you have to develop treatment methods to deal with it. As Dan pointed out, the publicly owned treatment works don't even have the technology to remove the PFAS from the wastewater. It passes right through. So Micron and the other CHIPS Act companies that are building these big new plants, they use the phrase collection for offsite disposal. Well, that's a lot more complicated than you might think. Removal of PFAS from wastewater, there are a few, these are three of the methods that are used here, but the effectiveness depends upon which PFAS you have, and all these hundreds of things that aren't PFOS or PFOA, the volume of the water, the concentrations of the contamination, and what else is in the water. So the idea is you're supposed to remove the contamination as close as possible to the source, the part of the plant where you're actually using it. But even that, which method you would use to remove it depends upon the particular situation. Again, the volume, concentrations, co-contaminants. And then as far as we can tell, offsite disposal means thermal treatment, incineration. And so they're sent off to another community where they're burned, but it's not clear that the risk is removed. They're releasing products of incomplete combustion into the environment as a result of the so-called disposal. You can skip this slide. I put this up just to show that there are many methods of treating and disposing. If you really want to know this, look at the recording for this morning's program. They did a great job of presenting some of the emerging technologies for destroying PFAS and including in wastewater. And I was really impressed by the progress that's being made because we need that. We can't just treat, so-called remove PFAS from the wastewater. We have to destroy it because otherwise it just ends up in the environment in one form or another. So here's what I'm calling for, and I work nationally with a group called CHIPS Community United. First, industry has to disclose more. There are some studies from Global Foundries on their effluent that have been done, but they haven't been made public. What are the other companies doing? They know there's a problem. We've heard, I've gone to meetings where they talk about it, but we don't have the data. We need better sampling and analysis methods because method 1633 only captures 40 potential PFAS out of the hundreds that are used by the industry. We need requirements for destructive treatment. Again, that's what this morning's panel was about. Just removing it from the wastewater doesn't solve the problem. Again, these are called forever chemicals because they're persistent. And the risk isn't just their direct toxicity, but the fact that every time something is released into the environment, it adds to the environmental load. So the goal should be stop releasing it into the environment. We can't count on the publicly owned treatment works to do it. We should count on the manufacturers like Micron to basically aim for zero discharge of PFAS from their production. And my personal preference, even though we do need effluent guidelines, the numbers for what they can release, the goal should be really to require the use of one of the technologies that we heard about this morning or something similar to basically destroy it all at the point of use. The numbers, we don't know how accurate those numbers are given the assumptions we have to make to come up with toxicological goals. Therefore, the goal should be don't add any more of this to the environment. And companies like Micron and Global Foundries can easily afford to do that given the enormous investment that they're making in production. I haven't talked about fluorinated gases, but the semiconductor plants also release vast amounts of potent, persistent greenhouse gases, a majority of which are also PFAS, fluorinated gases. The goal in the long run, of course, is beneficial substitution to come up with other chemicals that can be used instead of PFAS. The industry says that even if you come up with some of those, it's going to take years to insert them. I tend to believe that because what they're doing is pretty remarkable, building chips with features that the size of 2 nanometers. So again, that should be the goal. That's going to be a long time before we get there. It's pretty clear to me what we need. We have to stop industry from releasing PFAS into the environment. A lot of people here, people who presented this morning, are working on ways to make that happen. And for me, it's a matter of activating citizens around the country through groups like Ships Community United so that we can pressure our regulators, push our treatment works, work with scientists to make sure that we can actually happen. This industry, well, PFAS wastewater is not monitored. PFAS in wastewater is not regulated. The only way that's going to happen is that the people who are affected by these discharges into the environment insist that the people who are in charge make it happen. So if you want to plug into the information that I'm sending out, collecting on this topic, here's how to contact me. So I think we have want to try to do any Q&A or?
Most of our time.
So thank you very much.
Thank you, Lenny. If you want to stick around, I know we've come up to the official end of the session, but I really wanted to have some time for discussion. So I'm going to invite all of our panelists to come on up. We have some chairs on the stage here, and let's give it a whirl. See if we could have some discussion. If you want to stand here, that'd be fine.
Okay, so just to be official in terms of the timetable, there is a break from 3 until 3:15, and then there's a poster session in the Gateway Center that starts at 3:15. But the panelists are here to address any questions that you might have. And the format that has been suggested is to take several relatively brief comments or questions, and then to invite the panelists to respond. Are there questions or brief comments that people would like to make to the panel as a whole or to specific individuals? Okay.
What are you doing with all the data that you're because you said you were going to start doing, plant-based data, you have data. Is that just stuff you keep in house? Is that something what are you doing with it all?
So we have our own YouTube page, thanks to some youngsters in our office. So any presentation I've given in the past, I record and post it to our YouTube page. We also have a report, is all the detailed chemistry. If anybody wants to play with that more, that's posted to our webpage, I think, in addition to the Excel spreadsheets. One thing I want to point out I didn't mention is actually the risk that we see from wastewater, biosolids, and the effluent from purely domestic uses. We don't have much manufacturing in Hawaii, so it's kind of a good background. The risk we see from biosolids and wastewater is really low. There's stuff there, but it's not that high of a risk. It's where you get industrial input from the U.S. military bases, we see much higher levels of PFAS in it. So as far as managing small towns, we talked about their wastewater and their biosolids. I'd put that at a lower priority than focusing on the industries.
I had a question for Evan, maybe Dan. New York does have some semiconductor production, like in Malta, the Global Foundries plant. Micron is planning to build one of the world's biggest plants here. What do you require, or what do you expect to require in terms of monitoring or treatment of PFAS discharges from semiconductor production?
Very good question. I have to be careful about this one. So for the situation where we have industries discharging to POTWs, those POTWs are, I think you mentioned Oswego. Yeah. So we're looking at adding action levels to the effluent of the POTW, which is going to trigger a track down and a source control, much like the mercury minimization programs. That's, in a nutshell, generally what we're looking at. It'll then be up to the POTW, with DEC's help, to address the industries that are found to be the sources. There's supposed to be some level of removal. How that gets into individual circumstances, I'm not sure. It's going to be a case by case.
And how about for Micron?
For Micron?
Micron also. So the thing is, you know that Global Foundries is releasing PFAS into your wastewater.
Sure.
It's not like you have to do a track down. You know it's happening. You know it's passing through, and you might be held liable at some point. I'm not saying it's fair, but you might.
True.
So what are your plans? I mean, the state of Vermont required that Global Foundries sample its final effluent. And I've seen studies, leak studies, well, leak's a good term, leak studies on Global Foundries in Malta. Do you have any plans to monitor, or are you monitoring and not releasing the data?
Yeah, so we definitely have some results. I personally am under an NDA with them, so I can't necessarily go into that here. As you have stated, that's the game that gets played. But what I envision happening, and this is pure speculation, is eventually my permit will get modified to have those action levels. That will allow me then to have the technical reasoning, the defensibility that the EPA requires in 40 CFR for me to then go upstream. Now, yes, pass-through, interference, that would end in a legal battle, right? And the county isn't going to go fight somebody that provides 3,000 jobs. That's just not what's going to happen. So I'm going to wait for my permit to get modified. Once it is, I'll have more teeth. I'll go upstream and do what we need to do.
Having seen the presentations this morning of all these companies that seem to have pretty exciting methods of not only removing but destroying PFAS from not just industrial discharges, I fear that those companies will go bankrupt before anybody requires the semiconductor industry to use any of their technologies. Any more questions?
Great.
So, and maybe this is for the DEC. So what opportunities are there at the present moment for a fab that has yet to come online to begin construction, what opportunities are there to put these kind of limits on, as Lenny has suggested?
The opportunities are challenging. The Clean Water Act, the way that it's written, is we're typically regulating compound by compound, right? And we know that that is very limited in addressing PFAS, and it's going to be a slow process if we stick to that. At the moment, the DEC's focus is on PFOA, is on PFOS. There are other parameters on our radar. Addressing the compounds on a much broader level is discussions that there are discussions happening within DEC. We have yet to reach any sort of plan that appears to meet the regulatory structure that we have to sit within. Now, in my mind, I think about disinfection requirements, right? We have a fecal coliform indicator parameter. Different than other pollutants, we address pathogens as a broad whole, and we require disinfection. We don't say you have to apply this technology or that one or this one or that one. We don't actually have the ability through the Clean Water Act to say you have to apply a specific technology. We just have the ability to say you have to meet a certain water quality level. There may be paths forward with PFAS if we get to a level of understanding of all the treatment and destruction technologies to show that they really do have such a broad scale impact. And if we as a DEC could get to the point of saying, this is a defensible and cost-effective solution, that could be an option. But I, at this point in time, we really are very early in the stages of trying to figure out how to do it on a whole.
So, and I want to give DEC credit because I actually think they're thinking outside of the box on this one. The action levels is one way to go about things, and there's no, correct me if I'm wrong, there's really no water quality based effluent limit for PFAS or for any water body. Right, exactly. So they're using a human health criteria at 10 PPT for this action level. So to me, that's thinking outside of the box a little bit to at least get this ball rolling. So I did want to give them a little bit of credit on that.
So I want to add that regulation, which is fraught with challenges, is one of three ways that a company like Micron can be forced to not only monitor, but remove and destroy PFAS from its wastewater discharges. The second method is direct state requirements. The state is providing funds to Micron. It's funding job training. The state could say, we will fund you to treat your wastewater to protect our public. This is essentially what Congress has done with the Department of Defense, where the Department of Defense has done a lot of work on PFAS because Congress has funded it too. So the state could do that. And the third one, which is the kind of work that I tend to do, which is public pressure. And, Micron is, doing all this PR because it's getting money from the state. It's going to be a huge plant. If the public raises the issue, the company may respond. They, it's a company run by engineers, and they may welcome the opportunity to solve a problem and to win credit from the public. Global Foundries has cooperated with Cornell and others in providing data because, in part, they're concerned too. So I wouldn't rule out public pressure, letting them know that people care about what's going into their rivers and lakes and their farmlands.
I just wanted to underscore what I just heard and have you correct me if I heard wrong, but I heard Evan say when asked how would DEC approach a micron-like risk, which is coming at us and will be here in 2029 probably. And you said, well, probably through putting targets for the wastewater treatment, the publicly owned wastewater treatment facility to meet, correct? No, but generally you said the scheme would be there'll be a regulatory framework around the wastewater treatment facility, and then it would move to work with Micron on source. That's what you said. But, you know, I was.
So Micron is proposing to discharge to the Oak Orchard wastewater treatment plant complex there. That's Onondaga County Water Environment, Onondaga County, WEP. Yeah, it's WEP. They have an EPA-approved industrial pretreatment program. So the same process that goes for other industrials that are added to their influent will be applied. So Micron is applying for an industrial pretreatment permit through that program. That's an EPA administered program. So that is actually Onondaga County and EPA are in charge of that. DEC is more informed. We are involved in discussions, but we do not administer the IPP. So Micron will get a local limits permit from Onondaga County. That local limits permit is driven by categorical requirements, and there will also be local limits applied by Onondaga County. What Dan was getting at earlier was that the action levels, which is what I referred to being added to the POTW's permit, that gives the POTW the teeth to then go upstream to the industrial discharger, say, what are you sending to me? And I can limit that. That allows the POTWs to say, what are you sending to the POTW? And the POTW can establish a local limit. So our action levels are an initial step. They are a trigger that says additional actions have to occur after that. What those additional actions are is a case-by-case situation. It depends on the concentrations coming in, what's the source. Someone said there's 1,000 places in that PFAS get used in semiconductors. Did you have that?
That's what the
Yeah.
consortium says.
Yeah, so it would be a very complex process, and the actual ending action of what has to get done will be determined through that process.
The key thing right now is when you're building a new plant, or in the case of Malta, Global Foundries, retrofitting, modernizing a plant, that's a great opportunity to apply new environmental protections. That, you know, Micron has a footprint, but they don't have a complete design. The goal, I think, having talked to environmental professionals in the industry, is that the people designing production take into account the environmental issues rather than addressing them as an afterthought.
Well, we're on the subject of Micron. So the environmental impact statement is going to be released June 4th. That's what we're expecting. There's a 45-day comment period. That document is controlling, according to the CHIPS office, the federal folks that are giving them $15 billion, is going to set the parameters for environmental protection. And I've been privy to see an early release of this thing. Though when you look at the water, their assessment of water, they're not looking at the impact on the Oneida River and then the Oswego River and ultimately Lake Ontario. That's not on the radar screen whatsoever. It's just not there. That's got to change, in my humble opinion. Okay. there's an opportunity to comment, 45 days. And we have groups working on this. Contact me if you're interested.
45 days, right? Yeah. Before we officially call the session to a close, are there further comments or questions for the presenters today?
Well, my question that I was asking before, and thank you for the clarification. That was helpful. It was Saratoga, you stated that you currently aren't taking action on global. You're monitoring it, and that's proprietary because you signed a non-disclosure agreement. And that if your permit were modified, then you would feel like you had. Is that modification you're looking for the same thing, the designation of action levels, what Evan just described as what they're planning to do? What is it? So that's DEC's new strategy, and that's what you're waiting for.
I don't know if I'd call it a DEC strategy, because the reality is it's the POTW and the EPA that regulate industries. It's not necessarily the DEC, right? The DEC is putting these permit limits in because that's what the DEC wants to do. But that does allow me, under the industrial pretreatment program for the EPA, to then have teeth to go upstream and regulate and sample and monitor and potentially force pretreatment. Does that make sense? Yeah, and I mean, DEC's gonna, oh yeah, so basically I'm waiting for DEC to issue those action levels. Yes, because if I didn't and I tried to go upstream, I'd probably get sued, right?
Replace some chat.
So then it kind of disturbs me that the 40 federal regulated items are nowhere near what we are really getting in chips manufacture. And so these action levels, how are you going to set them so they're going to address these thousands of chemicals that haven't been identified? I hear that you can test it for the precursor things, but how do you set an action level for precursors?
Anyone want to tackle
It's a good question, and I don't have an answer for it. No. I mean, I think to Evan's point that I don't think we can regulate 12,000 chemicals, right? I don't think that's possible, but there is the possibility of, and I'm not a chemist, so I'm going to hand it over to any of the chemists in the room, that you could do something like a total organic fluorine test, right? That then you could correlate that to risk, and then you could regulate a total organic fluorine. But I'm going to hand it off in case that's like wildly inaccurate.
So I heard this morning, but also I've heard in the past, that the treatment of target compounds can also capture or destroy the other compounds. So if you have a stringent standard for the targeted compounds that you've identified, and we basically require a technology like we saw this morning, you may end up destroying the ones that we haven't been able to measure. But that means because you may need more stringent action levels than you might have otherwise, because once you aren't using PFOS and PFOA, the toxicity goes down, and also the aquatic toxicity. Whose slide was that? The aquatic toxicity goes down as well. So you need stringent standards, or you simply find a way to say, if you have this problem, you are going to use a technology that is designed to treat the full range of PFAS.
To add to that about finding the technology that's going to treat for the full range, If we wanted to approach this on that level of saying, okay, we have a target or an indicator species, and we're going to apply a technology that we know is removing or destroying more PFAS, one of the challenges where we're at today with that is that we don't actually know that any of these technologies yet do that. So we want to see more research. We want to see the science continue to develop to support the evidence that says one technology or another actually does achieve a broader range of destruction or removal. For example, granular activated carbon, we know works pretty damn well on the long chains, less so on the short chains. So it would be difficult to say, implement a technology level, general, apply this technology and expect it to actually get that removal of the short chain, which is, I think, what you said we're seeing at semiconductors.
Yeah, but again, the presentations this morning, some of them said they could do it. Let's set up programs to allow them to prove it.
Sources.
We have a question from a remote participant for anyone on the panel. Doris Solarius, Portland, Oregon, would like to know if there are alternatives to PFBS. I don't know if anyone is able to comment on that.
The 2021 Cornell study showed that PFBS was the targeted compound that was most prevalent in the wastewater, although there was all the non-targeted. But the Vermont data that I have showed it was not near the top. So whether you can replace at all, there's a full menu of PFAS that industry uses, and without them giving us more information, we don't know exactly where in the production. Is it because they're producing it differently, or because they've substituted a different PFBA for the PFBS? This is why it's so important to get more data out. And again, some people in the industry are supporting studies, but we want to see those studies.
Okay, last call for questions before we formally call this to a close.
Your question about how to address different compounds. The EPA had tried to do that with the hazard index, and Roger had touched on it in his presentation. So essentially you weight the concentration versus how dangerous it is and add all that up. And if it's greater than 1, it's dangerous. If it's less than 1, it's considered safe. So ultimately that's what we're going to have to do, but that was just recently struck down. So, you know, dealing with legal and lawsuits and stuff like that. So now which states take a proactive approach and implement their own hazard index, that's something we're yet to see.
Sticking around. Glad you closed it.
Yeah. So no more questions on Zoom. No more questions here. I want to thank you all so much for an excellent presentation. So there's the presentations and great session. Thanks for sticking it out. We have a chance to look at posters and have some snacks.